This video is about 7.1, estimating a population proportion. When we're given a population like this and we want to find the population, let's say proportion, when your population is really big, sometimes it's hard to find the population proportion. But we can estimate the population proportion by taking a sample of this population and find the sample proportion. And we can use the sample proportion to estimate the population proportion. The reason we can do this is because proportion is an unbiased estimator. And another two unbiased estimators are the mean and variance. Now let's come back to estimating the population proportion P. If we want to use only one value to estimate this population proportion, the best value is the sample proportion, P hat. Because like we said, proportion is an unbiased estimator. So here we can say that P hat, the sample proportion, is the best point estimate of P, which is the population proportion. For example, say you want to find out how many people in the city drink coffee in the morning. It is kind of impossible to ask everyone in the city if they drink coffee in the morning. So you randomly selected, let's say 100 people, and let's say 32 of them say yes, they drink coffee in the morning. So in this case, your sample proportion will be 32 out of 100, 0.32. So this 0.32 is the point estimate of the population proportion. That is, what is the proportion of the city population that drink coffee in the morning. Sometimes a single value is not good enough to estimate a population proportion. We need to find an interval that will cover the population proportion. And that interval here is called confidence interval. Sometimes we abbreviate it as CI. Using the same example as earlier, say my confidence interval for this population proportion is greater than 0.3 and less than 0.34. And I'm 95% confident that this confident interval will contain the actual population proportion. And this 95%, we call it confidence level. To find a confidence level, usually we're given a value alpha, and the confidence level is 1 minus alpha. The common alpha values are 0.1, 0.05, and 0.01. And the corresponding confidence levels are 90% or 0.9, 95% or 0.95, or 99% or 0.99. Next, we'll talk about critical values. A critical value is the number on the borderline separating sample statistics that are significantly high or low from those that are not significant. For a standard normal distribution or Z distribution with confidence level 95%, the critical value Z alpha over 2 is defined as the Z-score that the area to the left of which is alpha over 2. Since the confidence level here is 95%, then you can calculate the alpha is 0.05, which is 1 minus the confidence level. And that means this area, alpha over 2, needs to be 0.05 divided by 2, which is 0.025. So this Z alpha over 2 is the Z-score that the area to the left of it is 0.025. You can find that value using chart or the technology, which is about 1.96. This is a chart with some of the common confidence levels, 90%, 95%, and 99%, and you can find the corresponding alpha values and the corresponding critical values, Z alpha over 2. Going back to finding the confidence interval for a population proportion P. We know the best point estimate is the sample proportion P hat. Then the lower limit of your confidence interval will be P hat minus a number, and the upper limit of your confidence interval will be P hat plus a number. And this number E is called margin of error. It is the maximum amount of difference between the sample proportion P and the population proportion P. Let me say that again. It's the maximum amount of difference between the sample proportion P hat and the population proportion P under the given confidence level. And the margin of error in proportions is given by this formula. E equals Z alpha over 2 times square root of P hat times Q hat divided by N, which is the sample size. P hat is the sample proportion, Q hat is 1 minus P hat. Let's look at one example. McDonald's had 33 orders that were not accurate among 362 orders observed. Construct a 95% confidence interval for the proportion of orders that are not accurate. A. Find the best point estimate of the population proportion P. And we know the best point estimate for the population proportion will be the sample proportion P hat. So let's look at the sample given to us. We have a sample size of 362 orders and 33 of them were not accurate. So that would be 33 out of 362, which is about 0.0912. B. Identify the value of the margin of error E. We'll use this formula. E equals Z alpha over 2 times square root of P hat times Q hat divided by N. So since the confidence level is 95%, we can use the chart we talked about earlier. The 95% confidence level corresponds to the Z alpha over 2 of 1.96. So we'll know Z alpha over 2 is 1.96. What about P hat? Well, we already calculated the P hat. P hat is 0.0912. Well, Q hat is 1 minus P hat, which is 1 minus 0.0912, which is 0.988. And N here is 362. That's the sample size. Plug in the numbers, which is around 0.0309. And this value is the margin of error. Now C, construct the confidence interval. The lower bound of the confidence interval is the point estimate, which is P hat here, minus E, and the upper bound of the confidence interval is P hat plus E. In our case, P hat is 0.0912 minus E, which is 0.0309. This will be the lower bound. The upper bound will be 0.0912 plus the margin of error E, 0.0309. So the confidence interval is between these two values, greater than 0.0603 and less than 0.1221. D, write a statement that correctly interprets the confidence interval. We can say that we're 95% confident that the interval we just calculated contains the population proportion, which is the population proportion of orders that are not accurate at McDonald's. You can also use StatCrunch to calculate the confidence interval. To estimate population proportion, you go to Stat, Proportion Stat, one sample, and since we're given the summary, not the data, you choose with summary. Okay, number of success, I remember was 33, and number of observations, it's 362, and here you choose confidence interval for P, and confidence level is 95%, so 0.95, and here you click compute. Okay, so over here you can find the sample proportion over here, and the lower limit of your confidence interval is here, and this is the upper limit of your confidence interval. And this standard error is not the same as the margin of error E. I think this value is the part without multiplying the z alpha over 2, which is the square root of p hat times q hat divided by n, that value. So to find the margin of error, you need to multiply z alpha over 2 with this number. That will be the margin of error.